This is for example 10. Now for 10b, 10b says find the value of angle x. In similar triangles, all corresponding angles are equal. It's just that the size of the triangle changes, bigger, smaller, but the angles are all the same. The corresponding angles are all the same. So since this is 83, its corresponding angle must be x, and therefore x is equal to 83 degrees. What is the reason? Corresponding angles of similar triangle. Okay. In the previous topic, we came across this phrase: corresponding angles of congruent triangles. Okay, so corresponding angles of congruent triangles again are the same. Corresponding angles of similar triangles also the same. Okay, this is just a recap from 3.1. Alright? Now your turn to try it 10. I don't think you need long. Just practice, go through the flow. Ratio of the three sides. Whether you take smaller triangle over bigger triangle over smaller triangle, just make sure you get three ratios that are exactly the same. And write down your conclusion. You have 1 minute for this. We see that, there is a possibility of getting either 3 over 4 or 4 over 3, depending on which side divided by which side. Whether it's from the bigger triangle on top or the smaller triangle on top. Zulu, are you okay? Okay, so do you need me to show you the working for this? Try it 10? No? Okay. Angle Y, what is it? 104. What is the reason? Corresponding angles of similar triangles. Okay, now next test to learn. So back to our visualizer. Let me make some adjustments. Okay. Now I have two sets of instructions. I would like to draw triangles, two different triangles with this information. Okay, I've got AB, the length in cm, I've got AC, and I've got an angle. Another triangle, I've got two different lengths plus one angle again. Let me sketch out the triangles first. Can I borrow a pencil again? I forgot to bring it. Thank you. I've shown you and I've proven to you that whenever you are given two sides of the triangle plus the included angle, we are able to determine whether it is similar or not. So this is known as the side angle side similarity test. Does it sound familiar to you? Side angle side? How about we call this the SAS test? Would you like to call it the SAS test? Why not? Yeah, it was used for congruency already. So please don't use this abbreviation. Instead, we should call it the ratio of corresponding sides and included angle are equal. So as long as our ratio of the corresponding sides, in this case being AB and XY. If I find the ratio of AB over XY, then I find the ratio of BC over YZ. BC over YZ. If these two ratios are the same, the purple one and the green one, they are the same. Plus, one last rule, one last condition. This included angle, and you are familiar with the term included angle, the angle in between the two sides. If these two angles are the same, you get to conclude that ABC is similar to XYZ. Okay? These are the only three tests that we can use for similarity, nothing else. So don't get confused with your congruent triangles. By the way, just to record this, your test is now going to cover similarity as well. Yeah. So chapters 1, 2, and 3. This will be the last part. So we'll go through some examples on how we can use our similarity test, the last and final test. In this example number 11, we've got two triangles. You see that they also draw in the same orientation so that we can see very clearly what are the corresponding sides, what are the corresponding angles. In order to show that these two triangles are similar, we're going to use our latest test that we learned. Ratio of the two sides are the same, plus the included angle is the same. So now tell me, these two triangles, the red and the green one, which ratio should we find first? Which side over which side? PQ over XY, yep, good choice. PQ over XY. And we see that, it is 5 over 3. Okay, because the values are given to us. Let's find the ratio of another side. In this case, there's only one other pair that's given to us, 30 and 18. So RP over ZX, again we have 5 over 3. With these two, we see that, yeah, they are the same. Since these two are the same, can I conclude that the triangle is similar already? No, there is one last condition to meet. The angle that is included, it is 86 and 86. So since we've got ratio of two sides being the same and the included angle is also the same, then we conclude these two triangles are similar, ratio of corresponding sides and included angle are equal. So this is our test that we need to quote. No, just write this, can read. Ratio of corresponding sides and included angle are equal. Okay, just take note that we only need two sides in this case. Okay, now find the value of x. Okay, find the value of x. How do we search for x? What are some clues that we have? Yeah, we use the scale factor, right? We saw that they are all supposed to be the same. So this also implies that QR over YZ should also be 5 over 3. Because, reason is because triangle PQR similar to triangle XYZ. Or we can state that the ratio of corresponding sides are the same for similar triangles. So QR, we know that it is 35 already. Let's replace it with 35. YZ is simply x. Now I can solve for x. Okay, 5x equals to 3 times 35. X must be 3 times 7, which is 21. Okay, so that's found over here. Okay, so your turn to try it. Try 11. Thank you. Right, so to prove that these two are similar, we go through our checklist. Angle, angle, angle. I don't have two angles, so I cannot use that. I don't have all three sides because there's an unknown over here, the y over there. So I again cannot use, as I don't know why, I cannot use my ratio of 3 corresponding sides. I'm only left with one last option, which is side angle side similarity test. Okay, so 6 and 9. 6 over 9 we get 2 over 3. Then let's compare another ratio. We've got 4 and 6. 4 and 6, which is again 2 over 3. So we see that these two ratios, they are the same. One last thing I need to check will be the included angle, which is 127. Okay, so since that is given to us, we conclude that ratio of corresponding sides, included angles are equal. Therefore, ABC is similar to LMN. And finding the value of y, I'm sure you don't have a problem with that. Okay, using our scale factor. Any questions? No, okay, then we go to something more challenging already. Go straight to try 12. I give you 10 minutes for this. Okay, we will stop at 123. Okay, so here we have 3 parallel lines. Got AB 30, BC 15, CD is 10, B is X, the other one is Y, straight lines. Find the values of X and Y. Okay, I want to find the value of X first. I see that I've got this particular triangle that I've drawn on the whiteboard for you. Do you see a triangle in a triangle with parallel lines? We should be able to prove that the triangles are similar. So let me draw the two triangles. Okay, the smaller one, ABE. A, B, and E. Fill in the blanks. This is 30 over here, this is X, and this is parallel. So we've got a bigger triangle. I'll just highlight it. I'm not going to draw it. My job I would like to prove that these two triangles are similar. Because once I've proven they are similar, then I can use ratios of sides to find the value of x. So that's my objective now. These two angles in red, they are the same. In fact, they are common. So angle EAB equals to angle DAC. Common angle. Okay, one angle down already. Another angle, ABE, ACD. Okay, so these are the two that I'm trying to prove that they are the same. And obviously they are the same. Angle ABE equals to angle ACD. What is the reason over here? Recap. Sec 1 work. What is the reason for them being the same? Corresponding angle, yes. Corresponding angles, parallel lines. Do we need to write the reason? Yes, we do. Okay, since sec 1, you should have been memorizing it already. Right until now, it should already be in your brain. You don't need to memorize already. If you still find yourself working hard to memorize it, then please try very hard so that when it comes to the tests and exams, you have an easier time. So these two angles being the same, I can now conclude that since all three pairs of corresponding angles are equal, then triangle AEB similar to triangle ADC. Now that I can say they are similar, I want to find a scale factor. Okay, eventually I'm going to have a x over something equals to another fraction. Make sense? X over something must be equal to another fraction. So, x over what? I like to put my unknown on the left hand side in the numerator so that it makes my work easier. You can choose to put it on the right hand side, the denominator, up to you. But you need to manipulate after that. So, my recommendation, put your unknown top left. So, x over what? What should the corresponding side be? What is the value? Or the name of the line segment corresponding to x? DC, okay? You can choose to write down everything down first. So x over DC is supposed to be equals to, DC, yeah? It's supposed to be equal to what? Another pair of corresponding sides, right? The ratio. Do you have many options to choose from? So what should it be? AB over AC. Do you all agree with this? Look at these two triangles. Corresponding sides. X over DC and AB over AC. You must look at the triangles, huh? Shufi, what do you think? What do you propose? You look like you are disagreeing. So you think that DC equals to AB over? Okay. How about this, huh? You think that it should be X over DC equals to BC over CA. Okay. We are supposed to compare the ratio of the corresponding sides of triangles, right? Okay, so X over DC, very clearly we are referring to this part divided by this part, yes? Now, when you say BC, do you see a BC inside this triangle? I don't have, right? So why would you want to use BC? Instead, your BC is over here, which is not part of the triangles we are comparing. Okay? So don't make that mistake, huh? So this is what we should have. X over DC is AB over AC. Therefore, X over, now we can substitute in values already. X over 10 equals to AB, which is 30, over AC, which is, how much is AC? 45, yes, which is 30 plus 15, huh? So therefore, we get that X equals to 300 over 45, which is 300 divided by 45. 6.66. So I should write it as the exact value, 6 2/3 cm. That's for X. Okay? Harry, do you get a different answer? Oh, are you supposed to leave in 3SF? If it is exact, you should leave it as exact, right? If it is exact value, you should leave it as exact, isn't it? Oh, what is not exact value? 300 divided by 45. 300 divided by 45. How much is 300 divided by 45?